on a second one. And some of that is going to be also, actually getting on the machines and cutting it, because sometimes, well, usually, a lot of the information starts making sense once you start actually cutting your toolpath. And I can make some time to come in, depending on what's convenient for you guys. So, when would be convenient for you guys to come in and actually cut, or to sit with me and get some one-on-one attention for the programming? How about you, Ms. Ariel?
Um, in the mornings would be better. I can't really do weekends right now.
Cool.
I keep getting filled up with things.
How would you feel about, like, what's morning to you?
I need to be back in Everett by like 1.
Like 1. Okay. How would you feel about a Friday morning?
I can do that.
Yeah. Because I bet you in an hour's time, with me, you'll be feeling a million times better and be at speed.
Okay.
Yeah. That's my thought. Same thing for you, Mr. Kenneth. When would be good?
Not sure. Probably weekends. I'm pretty well booked all week long.
Okay.
And even the weekends are pretty rough right now. Like last weekend was Mother's Day, and
Oh yeah. Oh yeah.
my dad's coming to town. He'll be here. He'll be here this Wednesday, and then through the week, and that's going to make things even more busy.
Right. Well, I don't want to put burden on you. I just want to provide you with a chance to get some ideas clarified and to feel more comfortable with this stuff. I just want to help.
Yeah, I'd like to actually. You're talking about running the midterm on a machine, right?
No, no, no. Only if you want to, but you don't have to by any fashion. It's more of
Oh,
I just wanted to see what you were going to do, and I would have a better idea as to what you understand or not. We don't have to actually cut it. If you want to, you can.
well, I'd be okay either way. But what do you mean to do what we want to do?
Well, as in, the part that I do want you to cut is the block and peg.
Okay.
You know, it's as dumb as it is. It is, it has some very important features that help lock in some understanding of what you're doing. Yeah. Beyond that, if you want to come up, after you have finished that one, if you want to come up with a design, do it. Let's cut it. Let's do something that's going to be more exciting for you for the last half of the term. The first one.
You want to actually cut that block and peg?
I do. Yes, absolutely. And if you can cut it at work, if they'll trust you, fine. I don't care.
Go over it.
Was that?
Did you want to go over like how we would cut it, or?
Absolutely, yes. Well, like if you're going to run it on my machines, I have to look at it first.
Yeah.
If you're going to run it at work, I should look at it first, but I'm not going to tell you what to do, right? Okay. Once that's done, then I will have proof that you have sufficient understanding that we can do something more exciting.
Okay.
Does that make sense?
Yeah.
Yeah, cool. Okay.
So should we go over, would it be over, would we fine to go over that on the weekend?
And we can certainly do that on the weekend. Absolutely. Jennifer oftentimes will give people credit for cutting CAD CAM parts during her class.
Okay.
So yeah, let's talk about that
Um,
for certain.
Okay, and then I was curious if you were able to get into looking at my Fusion files
Where were you putting it? Because I didn't see it.
under Team Shoreline.
Shoreline. Oh, I did not see that one. Okay, okay.
That's what we called it that day when you invited me to do something and you helped me set up that.
Oh, I didn't realize you named it that. Okay.
Did you see it?
I see Team Shoreline, but I'm not seeing your project folder.
KDR something or other.
No.
That's a big thing. I got to figure out how to
Okay.
actually
So what you want to do?
get it to where you could see all the stuff I've been
Yeah.
thinking.
So you need to give me permission to see it.
Well, I had set some kind of permission thing.
Did you? Okay, I'll try
Yeah.
again. I didn't see it in my email, but maybe it went to the spam folder by accident.
Maybe.
Okay, we'll hunt through that. All right. In the meanwhile, I thought we might go into an entirely different topic.
Okay.
So here we are back in 215 spring. So we have covered so far facing, periphery. We have talked about pockets, spotting, drilling, and tapping. We haven't gone into those a whole lot yet, but I fear you guys getting bored. So I wanted to start in on a new idea and then circle back to those again as a reminder. So let's take a look at the glorious and lovely world of Lathe. Okay, so I'm going to close this one here. Let's start a oh, that's not right. Lathe project 1. So basically the creation is going to be largely the same, but I want to look at some different ways of designing in here. So what I think I'm going to do is after I
draw
give
like
you guys,
half of it and revolve.
that is absolutely one way of doing it. We're going to look at that method as well. But what I'm thinking I'm going to do is give you guys a blueprint. I'm going to show you a couple different ways of making a top today. And then give you guys you can either design your own design your own top, or I will give you a blueprint for you guys to try. But how you build the design based on the blueprint is there are so many different ways, so very many different ways. It's, oh God, good grief, yes. So that'll be up to you. I wanted to wait for this towards the last quarter of the term because it can get a little weird here. Why don't you get some of the other design elements down first? Okay, so let's start with something that's more like what we were doing with the mill. So I'm going to grab that here. How big do we want to make this top? 1 inch or 3/4?
I can't see anything.
Did I not share screen? Oh, well, for Pete's sake. I thought I had. Sorry. Here we go. Okay, so everything is still basically the same. Do we want to go with a 1 inch or 3/4? Top. 3/4 top. I will take that answer. All right, and then here we are. And that's going to be our stock reminder. So I might make that one construction. We'll see. Okay, and then I'm going to, I don't like looking down on it square oftentimes, so I tend to like to tip it just to explain what I was doing there. And I'm going to over here and let's say, we want to make sure that we turn some of the stock diameter, but we don't want to risk leaving mill scale and such. So I'm going to take some of that down. So if I take that down to a 0.725, that's going to leave about 13 thou per side to get turned on the lathe. That should be enough. Make your own decisions on that. Okay, and then I'm going to extrude that a distance. I am feeling like an 1/8. So this is going to be the 0.125. This is going to be the flywheel essentially of the top. Okay, then from there, we're going to need something to hold on to for op 2. Op 2 generally has to be more delicate, more careful. So I'm inclined toward putting that grip on the spindle side, the part you grab and turn. So I'm going to say, let's create a sketch, and we're going to create that on the surface here. So that becomes my sketch plane. And I'm going to create a circle there. I'm going to tell it to be a 0.5 diameter. And then I'm going to come up to solids, and I'm going to extrude just that middle ring. I'm going to extrude that out. Let's stay with the 1/8 inch theme, see if we like that or no. There it is. Ta-da. And then I'm going to do it again. And this is going to be the spindle handle, whatever you want to call it. And I tend to like when they are 100 thou diameter. But since we're kind of on a 1/8 inch theme, maybe we're going to keep that 1/8 inch. Sure, why not? And then we're going to extrude that out. And let's look at a 1/2 inch. Sure, why not? We can make changes if we want. Okay, the part that actually touches the table. Let's do that. There's lots of different ways we can do that. But since we're kind of on that extruding out theme, let's keep going there. So I'm gonna grab that one there. And let's say we're going to make another. All right, fine. Let's keep on the 1/4 inch. Keep going there. Sure. And now I'm going to extrude that out a distance. Let's say 1/4 inch. That might be too far. We'll find out. All right, so there's our basis. So now we're going to start modifying that. We don't necessarily need to put in fillets down here, but I think oftentimes I like having one that's going to be slightly larger than the tool nose radius of my finish tool, so I can get a nicer finish there. Okay, so I'm going to come up here to fillet. And let's say we have that one and that one be, so we've got a 15 thou tool nose radius. So let's look at a 25 thou, see what that's going to look like. Yeah, okay, let's try that. And then I want a nice round top here. So let's make that a 0.0625. So it's going to be a sphere. But if we wanted a flat up there, we could shrink that to something, right? Make your own choices. But I think I'm going to go with the 0.0625. Okay. You know what? Maybe I'm going to press Control, and I'm going to add this one down here to do the same thing. So they both have the same round. Yeah, I like that. That's cool. Okay. What's that? Control. So you can add to your different groupings. I don't know how to remove. Might be just double click on it. But press Control and you can add to these groupings. Selection set, I guess they're calling it. Yeah, I just learned about that. Okay, I'm going to create a new one here just for elegance. And I'm going to experiment. What if we make that a 1/4 inch? See what that does. I kind of like that. Sure, why not? Give that. Oh, I have an idea. What if I select this whole face here instead of grabbing an edge? And I give that a 50 thou. I think I like the look of that. And then I want to edge break up here on this edge. Maybe I actually want to make that 50 thou also. So I went back to that last face. I select Control and hold it. And then I grab this edge here. Let's see if that did not do it. Okay, fine. Okay, see what we did. Kind of hard to tell with all those lines. Sometimes I like to go, not that one. Go over here into display. What are you doing? Go into display settings. Squirrels. Go up here to display settings, go to visual style, change it to shaded. And I can go back to home and that'll take me back. There we go. And it's a little easier to see what it's going to look like in reality. That's not bad, but I think I want more sweep right here. Excellent. Well, since I designed those, That's not a surprise. Okay, so maybe I want to change that. So I'm going to go back to this one and edit features. And I'm going to find. Oh, right. That was this one here, wasn't it? Oh. Let's see, I'm gonna turn the lines back on. Get out of my way. Fusion, not Fusion, Zoom. There we go. Huh. Can I remove that one? I can. Haha. Okay, so what I did was I highlighted one of the selection sets, pressed Control, and then I was able to remove an edge from that particular selection set. Neat. Okay, I'm gonna add something to that one, and let's make that instead an eighth of an inch. Ooh, I think I like that. Okay, there's my design. Ta-da! And that's very akin to what we've been doing up to now with how we built our forms for the mill. Any questions on that? Waiting to see if anyone is typing.
I'm pretty sure I'll have some questions when I'm actually doing it, but I'm trying to watch so I can see, and yeah, I'll get stuck when I'm doing it.
I totally understand that. Okay, well, I'm gonna save this where we are now. Boink. And now it has gone to the folder that you guys all have access to. You can see it right there, so that you can open it up and look at it at home if you wish. And remember, down here, you have the timeline of how I went about it. So you can see that process. It's not the same as a video, but in some ways better, because you can look at it at each step of the way separately. I don't know. Make your own decisions. Okay. Let's look at this another way.
So I haven't been able to open up these files to follow those timelines and see how that was done.
Really?
I don't know what's going on, but I could see the files. I haven't been able to open them.
Is anyone else?
Maybe I haven't learned how to use Fusion all that well when it comes to moving files and all that other kind of stuff.
Okay.
I still have a lot to learn when it comes to that.
Okay. Well, let's call that the homework assignment for between now and Wednesday. Is I want everybody to try to get into the SEC Manufacturing 215 spring of 24 and see if you can open up these files. And if you can't, then we'll make that the lesson for Wednesday.
I can get in there. I just don't know how to open them. Like I could click on them and
Weird.
yeah, I can open them.
Okay, well, we'll have to figure that one out because that's important. Okay. I didn't realize that. I'm sorry, sir, that you had been struggling with it. Okay, so let's try another method for doing a very similar thing. I'm going to now create a sketch. All right, now, unlike usual, I'm going to grab line, and I'm going to grab center line. And from center line, I'm going to take that down along my X a ways more than I truly need. All right. You can make your own choices as to how you go about building this. I tend to like using rectangle myself. So I'm going to go there. bring this down a distance. I don't really care what it is right now. And I'm going to say, all right, that is going to be 0.5 long. And this one is going to be 0.0625, which is a 16th, half of an eighth. Okay. And I'm going to, okay, there's going to be the flywheel. Oh, no, that's going to be the part we grab on for op 2. So here's going to be the flywheel. And here is going to be the tip. It's going to touch the ground. Okay. So now I can say, all right, I want this to be 0.125. I want this to be the same. I want this to be 0.25. And then this one to be, well, we'd gone with a 0.725 earlier, and so I'm going to divide that by 2. There we are. This one was a 0.125. And let's go with a line that is construction, and it was go. It was 0.25 long. So if I'd say coincident of, well, let's try something else. Let's drag this down to here and see if, oh, I know. I will trim that. So now I have a line endpoint. I can say I want this line endpoint to be coincident with this line endpoint. There we are. Okay, cool. Now, let's see. We were going to use fillet. And I'm going to put a fillet right there that is 0.0625. Oh, I don't want that to be construction. Try that again. There it is. Lovely. And I had put a value in here that I don't recall. Oh, yes, I do. Oh, look at that. It's trying to do the wrong one, isn't it? I don't want that. Let's try grabbing that one and then this one. Aha, there we go. 0.125. There it is. And then I had, let me hit that enter. And then I had one between there, and that was it 25 thou? Anybody recall? Let's go with that anyway. Okay. And then we had a couple 50s, as I recall. Tell me if I misremember anything along the way here, by the way, guys. That, and that were all 50 thou, I think. And then I needed something in here, a curve there. So I've got a couple different ways of doing that. But what I think is the easiest is if I just make a circle. And was that, did I go with the 25 thou on that diameter? Yeah, let's look. Should have written that down. Oh, well. So now I can drag that over so it's nearby. It's usually a good idea to drag it nearby because then it doesn't have to think as hard and make poor choices. Oh, no, it was a 25 thou or 250 thou radius. So that's going to be a 0.5. There we go. Okay, so I'm gonna get that nearby. And so now I hit escape a few times. I can go tangent. I say, I want this tangent to that, boink. And I want this tangent to that, boink. And I then start trimming. Okay. Here we are. Now I can go over here to solid and go to revolve. And there we have the same top made in an entirely different way. Right? It does look shiny, doesn't it? Okay, let's save that. And this is lathe 1.5. Lathe project 1.5. Save. Okay. So I'm going to come over here now and open up lathe project 1. See how I did for remembering those same values. Okay, looks pretty good. So that's what Mr. Kenneth was talking about, of revolving it, of drawing half the project. Now, one of the things that had to happen, by the way, on 1.5 is, and now that's kind of interesting in terms of our timeline. I only have 2 points. I drew it and then revolved it. Now let's go back to that drawing. Edit sketch. Now you see it's that light blue in here so that we know it's going to revolve properly. And that happens because I put that center line down first. You notice by getting rid of the center line, that's not blue anymore. I can't revolve it. And normally, I would have to have a line that goes from point to point. But having just a vague center line, it understands, okay, this is what everything's going to be revolving around. And it has a better idea of what I want it to do. That's kind of vague, but did it make any sense? Little maybe? No? Okay, fair answer. Basically, it's got to have an axis around which it's going to revolve. There it is. Okay. There it is. Okay. So those are saved and available to you guys. I want you to try to get in there and try to find them. Ariel, do you have any questions on what you saw so far?
No, I just have to try to do it myself before figuring if I have questions or not.
That is so much truth right there. Just like Kenneth said, it makes sense right now, but then once you do it, oh, what? Now, I am concerned about this design for 2 things. I did not leave it much flat space for the collet to hold on to for op 2. And this fillet down here might be too large. It might interfere with the collet and cause this to kick to non-concentricity. But I'm going to pretend everything's going to work out fine, and we can test it later if we want. Okay, so from here then, let's talk actual cam. All right. Now, happily, Fusion's lathe software is less weird than Mastercam's. Mastercam's lathe software is radically different than their milling software. I'm convinced they didn't make it. They bought it from someone else. Anyway. So I'm going to go from design over here to manufacture. Here we are. There we go. All right, so first we need to do our setup. And for that process, I'm going to go to models. And I'm going to turn my sketch back on. Oh, this one didn't have that. That was on the other one. Well, let's see how it goes without the model like I usually like to make. All right, here we are. So going to set up, Duke. Waiting patiently. There it is. Now starting out with the square stock, and that's fairly improbable on the lathe. So I'm going to come over here to stock, and I don't have my stock model this time. And sometimes I don't actually make a stock model for the lathe because I'm going to have a whole bar in the lathe behind it. And that can get a little weird in Op2. So make your own choices there. Mode, I'm going to go with a fixed size cylinder. And I know my stock diameter is going to be a 0.75. And my length, oh, that's wrong. That's not quite right, is it? So let's select our axes. And remember that center line we had? Isn't that nice to have now? Okay, well, here we are. But that's perfect stock, and that's a bit improbable, isn't it? So let's add a little bit to that length. Let's call it, oh, 1.25 inches. Now, we have it rounding up to the nearest 1/2 inch. So that might be excessive. Round up to the nearest quarter. There we go. Model position. Well, it's dead center. That's not really what we want. Let's offset from front. Oh, wrong one. Offset from back. There we go. But we want some to face, so I'm going to give that 50 thou. 50 thou tends to be a good amount to face on the lathe, particularly if you're cutting steel. You can get away with less with non-ferrous materials. But remember, usually you're going to have run a part-off tool just before. And part-off tools create so stupid much heat. So there's a good chance that we have work hardened the face of the rest of our stock. So you want, when you pull out for the next part, you want to make sure that you face off all that work hardened surface. So you want a good 50 thou to face if you're cutting steel. Yeah. Okay, now I'm going back to setup. And I'm going to select my machine. Okay, here's where it can get a little weird. I'm still learning this myself. So this may not go according to plan. I just want to prep you guys for this. So if I come down here to Haas, there is no lathe in here. Oh, wait, okay, so I have it on milling. Let's try looking at turning, see if it's gonna show up now. No. No, it's not there. Okay. I don't know why they made this choice. because they have the lathe on their website. So why do they not include it? I don't know. So let's see. How did I do that before? Let's try clearing the filters. Nope. Trying to remember how I did this. Oh, it was in something else. Right. So I'm going to cancel selecting the machine for now. I'm going to come back to it. I'm setting this up for turning. Okay, so now here we are. I want my X positive lined up more with my drawing. Z is looking good. Because remember, we got orientation before we select location. Wait a minute, that jumped out forward. Let's go back to our stock. Offset from front. There we go. Much better. Okay, I want my Z facing the other direction, or my X, that is. So X from point, and I think I have a flat line in here somewhere. There's one. There it is. Now it's parallel to that flat line. If I wanted to, I could flip it, but I'm not going to. All right. And Y doesn't really matter. The safety plane is way, way, way out there. That's kind of ridiculous. I don't know why they do that. 100 thou is plenty. Some people just use 50 thou, but I think it's kind of scary. You can set up your chuck reference here if you want. I don't usually bother. Make up your own mind. Okay. Now the spun profile can get weird here. And we're going to deal with it a little bit, but then address it more later. So I'm going to grab my body here and say, yep, that's it. That's going to create. I said, yep, that's it. There it is. And hopefully it will play nice. Doesn't always. Okay. No. Post processor. 5:13:24. Program comment. 2:15. Top. Up one. Ta-da. Okay. So I had added a lathe before. If I remember right, I went into manage. I went into machine library first, I think. And I wait patiently. There it is. Okay. Fusion library. Going down here to Haas. Going to turning. And there's nothing there. Interesting. Okay, let's try something else. Instead, let's try going to the post library. And there's the SC10. I have done this before, and it can see it. But if it wasn't there, we would go Fusion library, vendor being Haas. Ooh, Haas. I can spell. There it is. Okay, so I go to the Haas automation, Fusion library, and here are all their Haasy tools, and I see a Haas ST10. We've got some other fun goodies in here. Now, we also see some other ST10s with L and Y. L, I believe, is long. Y being it has an actual Y axis rather than a C axis for multi-axis tooling. Well, we don't have one with a Y axis here. So if you have any troubles, here we have the pre-GNCs for downloading if you have an old version. But for now, we're going to go a Haas ST10. I'm going to grab that. And we're going to come up here to export. No, is that right? Can't be export. It should be import. Oh, it's because I already have it. Well, let's try export, see if that does anything interesting. Let's put that onto desktop. What's definition? Save. It won't let me. Oh, it needs a file name. Oh. Well, this is not going to plan. I think I should try doing this on someone else's account. Okay, I'm gonna try doing this later. I'm gonna make a false account so we can go through it there, because as I recall, after I had selected it, this right here became available and I was able to load it up. Okay, interesting. Let's import that. No, I don't want that. I am so confused right now. Okay. Yeah, it's not behaving the way it did in the past. Okay. Did go through that there, though. Let's go back and edit this. Is it going to let me now? Be nice. Be nice. Import. Ooh. Ooh. My computer. Fusion 360. Nope. Not it. Nope. Okay, well, let's cancel out of that. Clearly, I need to do more exploring because I got this to work on a different computer, but obviously I lacked some of the understanding that I thought I had. That's okay. We can do everything else.
You know, I think Fusion does that, at least with the version that communicates through the cloud or whatever.
Yeah.
Sometimes something works, and then all of a sudden the same thing didn't work.
You are 100% correct.
You could try it for an hour over and over, and finally the same thing you've been trying finally works again.
Yes, I have found the same thing. And usually when I can recognize that, when I can tell that it's not me, then I shut the computer down, go get a sandwich, come back. Sometimes
I found that works pretty good.
Yeah. But I think right now, it was more my lack of understanding over their error. So I'm going to do some research on this. I'm going to give you better data on Wednesday. Promise. Will it succeed? We'll find out. Okay. Well, all of that aside, at least we have stock. We have a profile and we have a model. Now, honestly, I tend to prefer the profile method for the lathe. So let's go look at some things though. First off, we're going to face. That's always going to be your first, unless you have a very good reason. That's going to be your first tool path. All right. We're going to select a tool. And we're going to come to turning tools, imperial or inch. Now we see that little spinning down here, calculating spun profile. So what it's doing is that it is looking at the solid that we made and trying to understand what that would look like on the lathe. And sometimes it gets it wrong. We're going to look at some stuff. Okay, grabbing turning tools. And I want turning general. And I can't see the names very well here. I mean, okay, great. I've got the codes, but who knows what the hell those mean. So I'm going to come up here and see once you get the double arrow there, Duke, I can slide that over. Yeah. And we want right-handed tools. Don't get yourself all confused trying to overthink it. Just telling you now, right-hand tool. What's that? Uh-huh. Okay, so amongst those, our roughing tools are going to be in the 30 thou range. Now you notice it's not exactly 30 thou. That's because it's actually a 30-second, which comes to that value right there. Okay, grabbing that, I'm going to select, and I shouldn't need to modify the tool at all. And it already gives me something pretty decent right from the start, right? Okay, so we're going to make some small changes. Now, feed and speed. Well, can we come back to that? Let's come back to that later. One thing I do know is your feed per revolution. A good ballpark is going to be 10 thou per rev. But we're probably going to change it once we do a little bit of research in a little bit. But I'm going to start there. That's going to be a decent, safe ballpark. Your feed rate per rev is for roughing is based on your material. Your feed rate per rev for your finish is based on your tool nose radius, slightly modified by your material. We're going to talk about that more later. I absolutely recommend use constant surface speed. That will speed the spindle up as you get closer to an X of 0. Chucking in a maximum spindle speed is a good idea, but you don't want it all the way up at maximum for the machine. So usually you don't need more than 4 thou. No sense in winding up something crazy, but there's times for it. We'll talk about that later. There we have our tool. Everything looks good there. Geometry. So that's going to be basically our Z reference to where we're cutting. And we're just using a roughing tool. So we're going to go model front, and I'm going to leave 10 thou for the finishing pass. Now, leave enough radial distance and Z distance for no less than 2/3 your tool nose radius. Most finished tools, unless you are cutting larger parts, most finished tools are going to have a 15 thou tool nose radius. So you want to leave 10 thou radially, no less. Anything less than that adds probability of mushing material instead of cutting it. Okay, bouncing over here to radii. That is far, far, far too much, but happily, it's nice that they label these. That's neat. Yeah, that's a neat feature. Okay, so inner radius. We are facing, so we want to go deeper than 0. We want to cut below by about our tool nose radius. Now, while we're roughing, it doesn't matter if it's perfect. So we had a 30 thou tool nose radius, but actually it's a 0.03125, a 32nd. So if I go 0.03 for the roughing, that's going to be good enough. Or I could do like a 0.0315. So it's a little bit past, or 0.032. We don't want to go a whole ton past the center line because that adds probability of chipping our tool. Okay. So it's going to do that one there. Outer radius is just set to our stock. That's fine and dandy. Our retract, I mean, I'd probably do like stock +1 or stock +50. It's up to you. Clearance doesn't need to be anywhere near so large as that. So if we go retract +1, that'll do just fine. It's up to you though. Passes. Well, we're just doing a facing pass, roughing, so we don't need to get terribly fancy. And we can see that it's coming down below our center line into the negative a little bit for that. So there's really not that much to do here for roughing. Make sure you're in computer. I know usually in milling we talk about wear, but in lathing, you generally are going to be happy leaving all that calculation up to the computer. Okay, linking. For the most part, these are going to be fine for facing. However, I don't want my lead out the same as my lead in, because I want my lead out to be either straight out or at an angle there, fine. But I want my lead in to be kind to my operator to be, I think it's 90. Yeah, 90. So it's going to wrap it in, wrap it down, and then feed straight down in. So my operator doesn't have to calculate and hope. They can see exactly where it's coming in. No surprises. Doink. There it is. One nice pretty face. Almost as pretty as mine. Okay, so now let's bounce over here up to turning, and we're going to grab turning profile roughing. Same tool. And happily, it grabbed the value we had put in on the facing, that 10 thou. Now, that's a nice little convenience. Keep it in feed per rev, please. I'm going to bring that down to the 4 thou so we don't just wind the crap out of it. Okay. Geometry. For roughing, I like using cutting edge rather than contact point because contact point can feed in too deep for roughing. So I'm gonna leave cutting edge. Groove suppression can be important. I'm gonna leave it off for now, and you guys will see why. Let's go over here, and okay, same thing. So inner radius is gonna be the cutting edge. Distance below cut, we don't need to because we already did that. Okay, to do clearance, let's give that the 200 thou from stock. Passes. I like even depths of cut usually. You can use pecking along. It's usually more useful if you're cutting stainless steel because stainless steel likes to bird nest. And so by using that, you can snap that chip. Stock to leave. You want 10 thou radial and 10 thou in Z. I'm going to leave off extend to stock and we're going to see what happens. Sometimes it needs it, sometimes it doesn't. It varies depending on your shape of your part. Linking. Okay. Before we mess with it, let's leave it alone and see what happens, and we can come back and change if we need. Let's run that. Here we go. Okay. So things turned out pretty good. Doesn't have a lot of lead in. I don't like that. I think I'd like more out in the front. And it's trying to cut this groove down in here, but it can't because of the rest of the tool. So it's trying to protect that. So let's help it out a little bit. I'm going to run this first to see what it's going to do though. Yeah, let's do that again, slow it down. Generally look pretty good, but zoom face. It's going to come in. Look how close that is. Ooh, I don't like that. I mean, it should be perfectly fine, but that can get a little scary for my operator, and adding another 50 thou won't hurt anyone's feelings. Okay. Also, we should go look and see what the step down is. It defaulted to something pretty good, it looks like, though. Okay, we have some changes to make. I do recommend running it before you make all the changes so you don't try to over control it. Fusion doesn't like that. So you need to know what to edit and what to leave alone. Yeah.
When you're tapering down on the backside, what's ending up, or what I'm seeing is the clearance on the backside of that cutter is becoming less and less.
Yes. So we're not going to do that. We're going to get rid of it.
But it feels like it could be just fine, but maybe.
Sorry, man, I can't hear you.
I mean, it looked like it was fine too.
I still can't hear you.
Oh, you can't hear me?
No.
Oh, I was just saying I thought it would be fine, except for maybe I wanted to see what you had to say about it.
Well, we're going to do something else that's better, so there's no point in wasting time with it. So, let's see here. Oh, okay. So we have maximum depth of cut going at 40 thou, 46 thou radially. And I'm saying that is wimpy. Forget that noise. Let's come in with a 100 thou. Yeah, buddy. Let's get in there. Let's see. Grooving. For the roughing, oftentimes I just turn off grooving entirely. Pow. Okay, so I made 2 changes. Let's see what that's going to do. Okay. Okay, look at that. That's going to be nice and aggressive. Let's go get a peek. There we go. And we go face. Pow. Ooh, there's a cut. Mm-hmm. All right. Okay, I like that. Now, however, I like to have my roughing go back to about the front face of my part off tool, because that will give an edge for my operator to discern if they're in the right place. Also, it helps remove the potential for razor blades. Yeah. Okay, so let's go back in there. Let's edit. And let's see, where was that living? Trying to remember. That extend to stock. Trying to remember. There it is. So it's gonna be that one right there. Model back. Then I'm going to offset that by 50 thou for to leave some to face on op 2, plus 1/8 of an inch, 0.125. So we're looking at somewhere between 155 to 175. So I'm going to do an offset of, since we're just cutting this out of aluminum today, I'm just going to give them 30 thou. So I'm going to call that a 0.155. Negative 0.155. There we go. So we run that. Voila. Feeling good. Okay. So now, oh, I know what I was going to do. I was going to give it more of a lead in the front. I almost forgot. Go back to our geometry and model front. We're going to offset that by 50 thou. There we go. So did you guys see where I made those modifications? That was in geometry. And we can change where it comes in and where it leaves here. Okay. All right. I like it. Now we're going to face again. Now, some people don't like to with the finishing tool. They just want to come in the middle and go. I've done that myself in the past. But I think I may have converted over back to facing with the finish tool. So we're going to go back there and go select. Now there's a strange thing that happened and I don't understand it. We're going to go turning general here. For some reason, there finish tool is in metric. And I don't know why. We're going to select that anyway. Give it a right click. And then we're going to go back in. And now we're going to right click and edit. And we're going to go to insert. We're going to change our units to inches. And that corner radius here, I can go to custom drawdown and find, so what we have there is a point, as a 15 thou tool nose radius. And I believe that's a 64th. Let's make sure. One divided by 64 is about a 15 thou tool nose radius. That'll do. Okay. But it gets super confused up here. I don't know what that code is. I don't know what to put in there. But I am going to say that description is a 35 degree with a 15 thou tool nose radius. Okay. Do what you like there, but that makes me happier. Still doesn't like that code. I'll probably delete that from, or make some changes to that. Or talk to my tool room and find out what that actual code is. All right. Now we had talked, let's bring that back down to a 4,000, so we don't wind up. We talked about how the roughing feed and speed is based on material. We're going to use the same surface speed as we do for our roughing. Again, we haven't looked it up, so we're going to have to come back through and adjust all that. But my feed per rev for finish is based on my tool nose radius. So we want less than a third of our tool nose radius, depending on the material. Some materials try to mush and give a bad finish or burnish more readily than others. I tend to like, for a 15 thou tool nose radius, most materials give me a nice finish at 3 thou per rev. Going below that, and you're going to build a lot more heat and create much more chance of work hardening. Make your own choices. Okay. All that, the rest of that looks pretty good there. Geometry, model front. Yeah, we want that just directly on the front of that model there as such. Radii. Okay, we're just facing here. Now you got to make a judgment call. Are you going to try to save time and have it just face knowing that you have already roughed? And so you could bring that down to your part, bring your maybe just a little bit outside, bring your retract and so forth, to save time? Or are you going to leave it out at your stock diameter like we did for the roughing, just in case someone tries to run it without having, if they try to run their finish without running their roughing? Depends on the kind of shop you're in and what kind of a doofus you're dealing with. You never know. So I'm not going to advise you as to what to do here. I'm going to say that when I am coding for students, I code for the outside of the stock and let it air pass. So it's safer. Make your own choices. Okay, I'm going to cut below that face by a 0.016, just a little bit past the center of rotation. Well, that looks fine there. I'm going to, yeah, that all looks fine too. I'm going to change my linking to, it is not going to lead in the same as my lead out. I'm going to change my lead in to 90 degrees. There we go. Now, again, this is potentially super crashy. Is this a good choice? I don't know. You're gonna make the boss happy as long as it doesn't crash. Okay, there we go. Zorch. Then I'm gonna go to turning, and you'll see why I like having that outline there that we had done earlier, that light blue line. Okay, so it grabbed all of previous for that tool. That's handy. Turning mode is outside profiling. Yes, please. No, we're not using a tailstock. We don't have one. Okay. So it's at model front, and I'm going to offset that by that 50 thou. I'm more comfortable when it starts out there. Back is going to be the same value we had done before with a negative 0.155. And for the finish tool, I like to go from contact point. Okay. Groove suppression, we might have to end up using. We'll see. I'll try to avoid it personally. Clearance. Okay. Inner radius is that 0, outer radius being the stock. Your clearance, we don't need 5 miles out there. Let's bring that into there. 200 thou. Passes. Okay, let's talk about spring passes here. On the lathe, unless we are threading, we want to avoid spring passes. So sometimes that means step turning. Oh, right. So sometimes that means step turning, and we're going to talk about that later in the term. Sometimes that means using a tailstock, which we don't have. Well, actually, we do have on one of our TL1s. So we'll talk about that one and its safety later. All right. So I only want one step over. And it can be, doesn't really matter what that value is because we already left it with 10 thou all the way around. Grooving. I don't want it to try to cut down in here. So I'm going to well, let's say allow axial grooving, even though it doesn't really matter because we don't have an axial groove. Anyway, Okay. So far, that looks just fine and dandy, but let's look at it before we start making changes here. I think I'm gonna have to make some though. Okay. Looking largely pretty good. We might have some issues in here, but I'm not sure. I absolutely do not like that lead out. If the operator, if the setup person tries to choke up with the chuck to reduce deflection, we're going to be crowding that chuck. I don't care for that. So I prefer to leave straight out. I don't love an angled lead in. There's an argue for getting a better finish that way. Also, look at that. What's going on here? That's not matching our design, is it? So that's part of the whole it's calculating based on the model rather than the line, and sometimes it calculates wrong. Well, let's make a couple changes and then come back to that one. So I'm gonna go to edit and let's deal with the first problem, that being that lead out. I don't like it that way. It's dangerous. So I'm gonna lead out at a 90. I don't want it to lead in at 90. So let's try a 0, I think, if I remember right. That's allowed lead to cut stock. Okay. Lead in length of 80 thou. That's kind of a strange number to me. I like rounding it. You don't have to. Lead in radius is at a 0 at the moment. Putting a radius on there isn't a bad idea if you're trying to blend cuts. Okay. Oh, that number's wrong. Let's go back and change that. Apparently that's supposed to be a, let's see. Lead in angle 90. Let's try a 0. Oh, let's lead in. Lead in 90. Lead out 90. Changes to 0. Nope. That is weird. Okay. Thanks, Fusion. You're goofy. Okay. All right. That's looking better, but we have some flaws in our toolpath. Let's run it and see what we get. Zoink. Yeah, we're hogging in nice. That's going to throw some chips. We're probably going to be doing some coolant evaporating on that. Okay. It's going to get so hot, the coolant's going to vaporize. Aggressive evaporation, yes. Okay, so happily, the approximation we were seeing earlier was just that, an approximation, and in reality, it is matching our profile correctly. Hooray. It doesn't always do that. If it is doing it badly, we can go in there and going into edit. I've had to do this of where was that? I had to go into model and then grab chain, open chain, and then grab each one of those little lines around there and so forth. So if it's giving you a bad interpretation of your part profile, if you have a profile line, you can use that to fix the problem. Yeah. But it's giving us a good one, and so I'm just going to let that go. Okay. Lastly, we're going to go, oh, not lastly. We're actually going to have a problem on this, probably. When on this roughing, everything's going to be fine until it hits right here. When it tries to go around that curve with a step that large, there is a solid chance that it will bend this spindle if it's too narrow. 1/8 of an inch might be strong enough. It might not. So what we can do is we can go profile roughing. Right? We had everything that we liked on that. So we're going to select it, right click, duplicate, then go to the one above, edit, go to geometry, drag this line up to here, and then back that offset. Actually, why don't we go instead to selection, select that line, change my offset to a negative 0.05. So it's going to cut that nubbin first, because this curve right in here is where it's going to cause the bend. So now I can go into this profile roughing, edit the second one, and I can change my geometry to being there. And it's going to take a little bit of extra time, but really not much. And that way it's nice and rigid when we cut that. Okay. How do we feel about that? Kind of makes sense. It would be better if I could make the toolpath incorrectly and then go run it on the machine and you guys see it. But such is life. Okay, now we could just part this off as it is and then leave this chunk here for op2. However, we're not going to be holding it by much on that op2, and I don't want to lose a ton of time. So I'd rather take some nice, big, aggressive cuts on op1 where I can. So I'm going to come up here to grooving, turning groove, bonk. I'm going to select turning tools, and we're going to go turning grooving. And we have a 0.125 width. And I can't tell from here which is what. So I'm just going to grab one, see if it looks close. Ah, it's got a button there. That's not the one. That's not what we have. So let's try something else. I'm going to delete that tool. And so it gave me that warning. Oh no, if you delete it, it's gone forever. No, it's okay. See, there it is. Let's try this one. There we go. That looks a lot like ours. So we're going to go back in now. Edit the tool. going to the insert. Okay. So our overall width, that's length, sorry. Our width is 0.125, but they're talking about back here. I think our groove width here is a 0.125, if I remember correctly. All right. Corner radius is a 64th. I feel better about all this. We should measure our tools, though, to be certain. Grooving, right, 0.125 width. All right. Gonna accept that one. Select that. There we go. I like it. Okay. Now, generally for me, I get concerned with grooving because it's rubbing on three sides and has a very large surface. So I tend to drop my surface feet per minute by about half. So if I go like a 400, I'm feeling more comfortable there. Do what you like. My cutting feet per rev, I turn that way on down to like 6 thou per or less. Sometimes for my part off, I'll drop it down to a 2 thou. But I'm not parting off, I'm roughing. So I think I will be safe at a 6 thou, right in between the rough and the finish. Okay. I don't want to try to rough or to groove the whole thing. I'm just doing that back. So I'm going to go with selection and I'm going to select that line there. That's fairly convenient. Back, model back, that's fine. Or is it? No, it is not, because that's going to create a razor blade. So let's back that off to a negative point. Oh, let's see what the 155 is going to do. See if we like that or not. Radii. Okay, well, I don't want to try to part everything off and come all the way down. So that inner radius, I actually want that to be a little on the thicker side, somewhere in there. So so that's going to be about a little more than 1/8 of an inch. That should be strong enough. We'll see. Outer radius stock, retract. Oh, it's all the way out to clearance. Let's go with stock and bump that out by 100 thou. Do that right? I did not. It's the wrong one. What? Something is goofy. I retract out to there. There we go. And then my clearance. So what I'm showing you here is you don't have to put in the exact numbers. Sometimes you can just drag it to what seems reasonable. Right? Okay. Okay. So let's see here. I don't want to allow a rapid retract. I don't believe compensation type is in computer. 40 thou back off. I do want a finishing pass, just one of them. And I want that step over to be, let's give it like a 20 thou. Okay, roughing passes. I tend to like full step down myself. You should experiment with what you like. Step over of a 40 thou is too small, in my opinion. So if it's a 1/8 of an inch across, let's see what like a 75 looks like. Because of the nature of all that pressure, sometimes I like pecking in there better. It defaulted to a 1/4 of an inch, not a 1/4 of an inch, 400 thou, that is. That seems a bit much. Let's drop that to, let's see what 100 thou does. Stock to leave. I don't want to finish with this tool, even though I said finish earlier. We're going to do that in op 2. So we're going to leave a radial step of 10 or 20 thou. I'm going to go with 10. And an axial also of 10. Okay. I'm going to leave all this alone until I see what it actually does. Ooh, that's kind of nice. Let's see what that is going to look like. Coming on in. Bump, 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 bump. Bump, bump, bump. Bump, bump, bump. Bump, 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 bump. Now that's dangerous, having an insert like that do a side cut. But because it was actually mostly angled and mostly on that inside corner here, I think it'll do fine. It'll put a lot of radial pressure to keep the tool in the blade. I think it's going to be okay. Was that? Oh, not like dangerous, but more along the lines of there is always the potential for the insert popping out from lateral pressure. And we don't want that. Okay. Let's exit that simulation there. And I'm pretty happy with what that did. So I'm going to come up here and part off. And same tool, but I'm going to drop that part off to more like a, well, yeah, let's leave it a 6. If you don't have a parts catch, so we have on the ST10 a basket that swings out, that if you turn it on, that can swing out, grab the tool, and you can just pick the part up outside without opening the door and without going swimming in the razor blade soup. Yeah. The TL1s do not have that feature. If you are making parts and every second counts, then you're probably going to want to find another answer. But if you're on, say, that TL1 and you're only making 20 parts, 5 parts, then instead of parting all the way down, I find it sensible to part most of the way and keep from knocking this part off. And so then the operator can reach in and snap it off. That way, again, they don't have to go hunting. Okay, so let's look at that perspective of if we don't have the parts catch. In that case, I'm going to slow this on down to make less pressure down to that 2 thou per rev. And again, my surface speed is much slower. less pressure. My geometry. So that was that model back, but I want to give it 30 thou negative 30 thou. So we have something to face for op 2. You can also, it's nice if you have less of a groove on the inside here to give an edge break so that the inside face doesn't cut anyone. But because we have this deep groove in here, that's pretty hard to arrange. You can fiddle with these numbers until you get it to work out sometimes, sometimes not. But again, that's only if you have the this backside cut. If you just do it coming straight back and then having a part off, then this chamfer is a very nice feature for your operator. Okay, I'm gonna turn that off though. All right. So my inner radius, I'm gonna offset that. Again, it's radius. So somewhere between 50 and 75, kind of depending on material. I'm gonna go with a 75 on this. No, I'm not. That's way too much. Let's drop that down to a 30. Yeah, it's gonna give us a 60 thou diameter. I think that'll be okay. Okay. Outer radius stock, fine. Retract should be outer radius plus 100 thou. And our clearance should be our retract plus 100 thou. Okay, so we're coming in relatively close to our stock, but it's going to start 100 thou out. Should be fine there. Passes. I want to use pecking. I like pecking. You don't have to. Pecking depth is a bit much there. So let's actually, I guess on this one I wouldn't need to because of all that material is mostly gone. So I guess I'm gonna turn that off this time. Sure. Okay. I do not allow rapid retract here. I'm contacting material. I'm not a fan. I know of other professionals that do whip right out of there. Make your own choices. Stock to leave. I want that to be a 30 thou. Oh, it's not updating. Let's turn that off and see what actually happens. Okay, let's try that. There we go. Okay, so I had left the 30 thou on that other feature, so I didn't need to double up. So you can see it's going to leave a little bit there. I might need to leave more. That's a good opportunity for going down with a setup person and say, okay, is this popping off or is it staying on the stock? Let's look at this one. Now, look at that machining time. Less than a minute and a half, not counting tool changes and rapids. That is profit. That is money, especially since we bulked off most of op 2. We might even be able to skip the roughing pass. That is groovy stuff here, guys. I'm telling you. Okay, let's run it. Doink. So even with the extra tool path to get that nubbin, we're making good profit. So then you sell this top at 25 bucks a piece. And the material costs you 50 cents each. That's step 3, profit. Right? For those of you who watched South Park. Oh, the step 3 profit is from South Park. Yeah. Terrible, terrible show. Timmy. Okay. Terrible, terrible human. All right, there we go. Nice. Now, having those 2 passes in there, I don't know, but I think I like it. There. That might be a little too skinny. We might need more meat on it. We might need up closer to like 100 thou diameter for that snap off. But all in all, I'm feeling pretty good about all of that. Gonna exit that simulation. Okay, now up to going into setup. Oh, I'm gonna turn my models back on. And my stock, my mode is from preceding setup. And I'm going to continue rest machining. So it doesn't try to cut what's already been cut. Going back over to setup, we know that it's turning. We want our rotary axis to be this center line there. Very good. Let's flip this around here. And our X is just fine. Let's try leaving all this for now and see what happens. Post-process. Well, that's not going to work out very well because I'm going to have two codes or 2 programs with the same code here with the 5, 13, 24. So I'm probably going to need to choose a different style of that if I'm going to do multiple programs in a day. Oh, well, so I'm just going to call this one 02. Poor choice. Oh, well. So here we are. And then this was Lathe project 1.5 op 2, something along those lines. I think I'm failed that previous setup. Now, because we don't have a machine, it's just giving us a WC offset of 0. Okay, fine. Oh, but our placement there is wrong. Let's go back to setup. Okay, we want this from the model. Where are we at? Origin, there we go. We want the model front. And we want to give that offset to be positive 30 thou, but it's going from the front of the stock. I don't want that. Nope. Well, let's try instead going. Oh, that's a safety plane. Oh, my mistake. My mistake. I was looking at the wrong thing. Okay. Well, it's not really giving me up. Okay, we're going to look at that. I might have to make some changes. We'll see. Previous, okay. Ignore the warning, yes. There we go, just fine. Okay, so this stuff isn't here, and so it's gonna register crashes. We're just gonna ignore that part. Okay, and where is my WCS? It is all the way out there. That is not what I want. Let's change that. Why are you doing that to me? Set up. Let's go. Oh, because I had selected that as the rotary, I think. So x-axis from that point? Nope. From selected point. There we go. That's what I want. Okay, so touch off then is going to have to go in the setup sheet that they need to touch off on the front of the part and inset by negative 30 thou. Right? Okay. Well, I still have a little bit I need to rough, so I'm going to use that roughing tool. I liked the idea of not, but I'm going to. So what I'm going to do is I'm going to be lazy. I'm going to say, I've already set that tool up correctly. So I'm going to say, select it, and then I'm going to duplicate. There it is. I'm going to select that face 2. I'm going to drag it down and drop it into setup 2. And then open that up, and there it is. So I'm going to have to make some changes. We're going to go in here and edit. We're going to move this over here. There we go. All that stuff stayed the same. My geometry, I'm going to say selection from there. Still with 10 thou. Good. Radii. Everything else should be the same. Let's see how it goes. Failed to generate. Well, fine. That was not going to be my friend. I don't want to fight with it, so I'm just going to go back to turning face. Let's drop that down to a 6 thou there. Actually, no, let's keep that 10. Not taking that much. I don't remember what our SFM from before was. It was 600 something. So I do need to go back and check that research, make sure we get that right. Oh, we got a groove tool. That was the problem. No, it would have been a different problem. Oh, well, doesn't matter. There we are. Okay. That's looking better. Front, and we're going to offset that by 10 thou. Radii. Okay. I don't necessarily need it facing the whole thing because that's already been done. Set my retract to there. This one to there. Sure, why not? Okay. That all looks fine. I want to change. So it's not the same as my lead in. Lead out and lead in are different. My lead in is going to be a 90, so I get no surprises. Failed to generate toolpath. Why? And it crashed. No, it didn't crash. What is going on? I'm going to save it right now because something is getting weird. So it does not like my setup. It is angry. Let's go find out why. Why are you displeased with me? Orientation. Which I model orientation. Nope. It's in X. I want Z to be parallel to this line here. Nope, not you. I want Z to be parallel to that line there. And I'm going to flip my Z. Everything looks fine there. Origin is what is selected. But my Z is offset. I don't like that. Okay, fine. Go back to here. Don't want to flip it. I want to go from selected point, and I'm going to select this point. X-axis is going to be perpendicular or a parallel to that one. And then we're going to flip it. And it is absolutely grumpy. Let's try selecting this. So I don't want to do the whole part. I just want to do that. And it is super unhappy with that. It doesn't like something I'm doing in that setup. So let's start over. Why is it being grumpy? My stock from previous continue rest machining. My Z-axis, I'm going to flip it. And X is fine. Everything looks happy there. Origin, I'm going to go model front. Safe plane is going to be model front. Oh, that's the chart reference. Model back. So WCS origin plus 100,000. Okay. I don't care. Whatever. Go. Okay, now it's happy. I don't know what I did before. I got it right this time. All right. Fine. Whatever. So I'm going to try this again. See, that's going to be happy this time. So duplicate. Then I grab the second one. Then I drag it down to setup 3. And then I open that up. Then I grab that face. And I'm going to go back into edit. I'm not going to worry that it looks kind of weird. Everything's okay. Because then it recalculated. Okay, all that looks fine there. Model front, offset 10 thou. Okay. And drop that down to there because that's most of that stuff is gone. And my retract. Sure. Fine. Whatever. Okay. Everything's happy now. I don't know what I did weird before, but everything's fine now. Okay, whatever. Pressing on. Profile roughing. So most of it's just been roughed. We just need to get this little nub in here, right? So we're going to go with geometry, drag this one up to there. And this one out to there. And that should do fine. They're going to leave 10 thou and 10 thou. And let's see what it does before we make changes. I don't want all that. There we go. Much better. Okay. Let's simulate. And it's going to say we're going to crash, but we can ignore that because this disk won't be there. Zoop. Nice. Okay. That's looking groovy. So now I'm going to go back to my, let's see, phase 2. Duplicate. Select. Drag. Goes to that blue line there. And then I'm going to right click, edit. And that all looks just fine. And then I'm going to come down here to profile, duplicate. And then, oh, sorry. I'm going to grab it, drag it down to here. Drag that face back up. There we go. That's what I want. I'm going to come in, I'm going to edit. I am going to go to geometry, model, chain, open chain. And it is thinking down here about something. That makes you select. No, you're not. Try again. What are you doing? Drag you back to there. And we're going to go into chain, open chain. There we go. I want that to go the other direction. There we go. And there. And there and there. Now, we do not want to continue past. We have already cut this surface here. We don't want to cut over it again. So actually a curved lead out is going to be our friend here. Okay. And so I might even give it a curved lead in as well. Kind of like it. Make sure there's nothing I need to do here. I think everything's okay. All right. Lead in radius. Let's give that let's start out at 1/8 of an inch and see what we think from there. Giving it the same. 100 thou, 80 thou. Oh, let's make that 100 thou as well. There we go. Now that's going to be a problem because our fixturing is going to be right here and we have just crashed. That is what is known in the industry as a bad thing. So it might be we don't get to have that lovely curve on this. So we may not get as nice of a finish. So I'm going to come back here and say, okay, fine. Let's bring that back to a 0. This one back to a 0. Yeah, it's probably going to do better. Now, if we could have our fixturing further back, then we could play with that a little bit more. But it doesn't look like we really get to. So let's grab everything and see what we get. Total time, less than 2 minutes. That is nice. Here we go. Base. Rough. 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 Nubbin. I would probably trim some of that extra dancing around that it does in the post processor, in NC code. And there's no need to warn anyone of that. You're just making the toolpath more efficient. Doesn't hurt a thing. Now, the danger here is in potentially creating deflection and bending the back part of it. So we end up, what's that? Oh yeah. So we could end up creating problems for our op2, but I think we're going to be okay on this. So here we go. And a lovely little top that may or may not spin well. Yeah. Okay. So I'm going to save that. It is now in there, available theoretically for you guys to look at, compare, contrast, make your own choices. I might have put in some more notes for the operator for some of those tool pads. Maybe, maybe not. But I would like for you guys to try that. You don't have to make the same model. You can do something different if you want. But I would like you to try to make a top of some fashion. Well, if you're not going to cut it, any size doesn't matter. If you do want to cut it, make sure that we have the stock. And we have a little less than, well, oh, that's right, I need to leave. So we've got about half an hour. So you can take that time to work on it, or you can go home to work on it, whatever brings you joy. Do you guys have any questions for me right now, though? That was a lot, wasn't it? That was a lot. But
Yeah, quite a bit.
yeah,
I gotta digest this for a while.
do it.
And practice.
What I mostly wanted to show you guys was that the modeling can still be the same thing, right? The first one I did is the same kind of stuff you've been doing. For the milling. But then I showed you another way of, because we have a round part, we can rotate. We can revolve our model. And then we have all that kind of tool pathing. And even though we have quite a number of tool paths, when it comes down to it, they weren't that much different from each other. If you can figure out how to rough, the rest is just going to fall into place. So if nothing else, I want you to try to figure out how to do a roughing toolpath. And we can build from there. All right. So you guys have 2 assignments to finish. So you've got we want to finish the milling toolpath. I think it would be fun to also for everybody to take home a top that they designed themselves. Wouldn't that be cool? And then
That'd be pretty neat.
yeah, I think that'd be a fun bragging point. And you can make it out of aluminum, brass, or steel. We didn't talk about speeds and feeds today. We'll do that Wednesday. Yeah, go ahead. And then there's potentially a third project if you want to, of whatever you want to do.
Okay.
If we have the material, you can do it. As long as you get your design past me. Right? But otherwise, we're kind of in playtime now. Right? I'm not going to have much more lecture through the end of the term. It's pretty much just going to be what we've done and actually cutting it. So after this week, I want you to bring me questions. That's pretty much all we're going to deal with. Me answering your questions so we can get this done. Every term, the last quarter of the term is when the real learning happens in 215. It's all been prep for this. So let's do it. All right. So you got another half an hour and then I'm going home. I got to make dinner. No, actually, my sweet babu has already done that. Yeah.
Okay.
All right. So I'm ending the meeting so that it ends Kenneth's recording. And have a good evening.